Okay, let's find this attraction, the magnitude of gravitational force between the masses. Of course, this force will have a direct relationship with the mass 1 and also mass 2. So the bigger the masses are, the bigger the force is. And the multiplication, because both of them has an impact on the force, the multiplication of them has a direct relationship with the force. What about the distance between them? Of course, the bigger the distance gets, the smaller the force gets. But that's why the distance must go on the denominator, because this is the inverse relationship we are talking about. However, I'm going to tell you something. If the distance gets twice bigger, the force will get 1/4 smaller. If the distance triples, the force gets 1/9 smaller. So it seems that the inverse relationship of the force and the distance is actually the inverse relationship between force and the distance to the power of 2. So the square of the distance has an inverse relationship with the force actually. This is the relationship, and in order to make this relationship to an equation, we would need a constant, and this constant is called G. And this is the amount of this constant of gravity, constant of gravitational force. G is actually, this is the amount. And if you want to know the unit of it, of course, this is Newton, this is kilogram, but there is 2 of them multiplied each other to kilogram square, and this is meter square. So the unit for this constant of gravitational force is actually Newton meter square over kilogram square. So if you want to write this, you have to write its unit, which is Newton meter square kilogram square.